Hello guys, it's Tony here. Today, I'm going to show you guys how I simulate a random walk using Python. So the random walk that I'm going to simulate is called random walk in a circle. What it means is that let me show you guys. So here's a circle and a guy on the circle. It chooses to either walk clockwise or anti-clockwise each step. And then the choice is based on a distribution of like a probability of him walking clockwise. I don't know, maybe for example, zero point 0.7, and then anti-clockwise is 1 minus p. So, and we need to show its step and its position each step, and then maybe so like zero point 0.7 probability of working clockwise. Maybe first three steps it will like go forward, and then the fourth maybe it will choose to work anti-clockwise. So that's the idea, and basically to use Python to show its position on the circle each time. Uh, we first need to like import some libraries. Circle, circle, random walk. So we only need three libraries. First, of course, math, and then Numpy, uh, and also we need to show the position on the plot. So of course, Pyplot plot. First, we need to set some parameter. The first is going to be the perimeter of the circle, and also you want to calculate its radius. Circle perimeter, and also radius, for example, 10. And, we also want to specify the length of each step. The length of step, maybe let's use 100. Then also number of step, one step, two step, 100 also. So the next is the probability of working clockwise. Let's set to maybe 0.56. Also, we need to like specify the worker's original position. What it means? Okay, I'll show you guys paint. We want to use the parameter it works. No, maybe like so if like we set it here, so this is the original position to be 0, and then if you work clockwise a step, and then this one step will be 1, and then if it work anti-clockwise, it will be, I don't know, for example, we have to make no, like divide this circle by m. So it's m part, and then this part will be n minus 1. So the idea is to basically use remainder to implement the position. So anti-clockwise is minus, and then clockwise is plus 1. So if he choose to work anti-clockwise, we minus 1, and then here's minus 2, but we use the remainder, so the position will be I minus 1, I minus 2, and so on. So here's the idea. Let's just set it to be 0. And that's probably all the parameters we need to set up. And then we need to just go on to define the random walk function. We call it a simple random walk. Of course, we need the original position. So this function is like what he chose in a single step, and then we upload its position. So basically, you want to return the integer. So his original position and the probability of him working clockwise, and then the length of each step. Maybe we also need the reminder. So we divide the circle by its perimeter. So we also need an we call it a step equals, we need to use the choice function, random.choice. So he choose to work clockwise or anti-clockwise. Minus the length of each step, and the second choice is the positive one is to work clockwise, and then distribution is of course and minus p and also p. So that's basically it. And return the position step plus original position, and get the reminder. Now here is the plots part. Of course, we need a circle. We just use plot circle. Yeah. Circle. Probably just the radius. So that's the x coordinate from minus radius to positive radius. So this part is we need to calculate the y coordinates. This is square root minus the x coordinate. Then we just plot it. Plot x, y, x, y. Maybe choose the color, I don't know, blue. That's the circle. We also we want to save the plot and make a GIF, a GIF out of it. You know, that's like the best way to show the steps. So save pick function, save plot. Pyplot, it have this save plot function, but we need to specific the file name. Just so this is the file name. We're just going to use integers 1, 2, 3, 1, 2, 3, 4. And then save it to make it GIF. We need to return the file name later on. After this, we're going to plot like the worker's position on this circle, basically. Plot position. So yes, position. What do we need here? Well, it's not going to be easy to plot based on the parameter. So we have to like convert the position into x and y coordinates first. Okay, so maybe we define get x and y from a position. So get x, y, the position. So we're going to use cosine sign. So we need to use the parameter and also the radius. X. Let's get this plot on. So it's on 0, 0. That's the origin. So minus radius plus cosine will be the percentage of the position on this circle parameter, and plus 2 pi, not plus, multiply by 2 pi. Y is sine. Return y. So we're going to use x and y in the position function. We need the radius. I is the number of steps. This is going to be the biggest function, I think. So each plot, you need to plot a circle, then plot the position. I don't know, maybe red and blue, good contrast. Maybe the title. What's the title? Random walk in a circle. Maybe also specify the probability of working clockwise. Mhm. If we want to make GIF, we also need the file names. So this function will return the file name. So file name is save function, the save plot function, save plot, and the plot takes the like the index of the file name. It's going to be I. No, it's I plus 1 probably. Because Python start at 0, so we start at 1. So the file name is going to be 1, 2, 3, and all the way to 100. Then we want to clear the function because we don't want to like show the first step in the second step picture. We each show one step and then return the file name. So that's, I think, and maybe I made it complicated. But I think that's all the function we need. So create the list file names list. Then basically just use the append to append each file name. So for I in range, I think it's length. So the number of steps specific earlier. So it's 100. We want to update the position using this function. So simple random walk is the original position, probability, length of each step, also the perimeter. And then the position, we want to like keep a record of its position. Y get XY position file name position XY XY are I. So now we append it to the list. That's it. Okay. And what? Oh, I missed the bracket. It should be good. It'll be good. Also, we need to plot our track of its position. So basically, it's this list. Plot numpy this. want to num want to plot that out. So this is the x. It's basically the step, the index of the step. The y is going to be its position. So plot x label, number of what? Steps. Plot y label position. Okay. Also want to save the plot. The title track. Not good. Okay, maybe the title. Not title. Track of position. Now we are going to make the GIF using image.io. For you, if you don't have it, use the I'm using Anaconda, so the prompt and use pimp install. This is pimp install image.io, and that's it. Image. So file name in file names image and image.io dot in read the file. That's it. Okay, we also want to save the GIF. image.io save. I don't know what to call it. Maybe just a final .gif. That should be good. Run. Okay, just wait for the result. And now we look at the result. Here is a circle random walk. And basically this is the like each step. So the first step, here work anti-clockwise. We want to find the GIF. Take a look. Okay. So yeah, he's struggling. So because the P is too close to 0.5. Okay. Track of position. So if you see a line like this, it's basically he's at position 0, and then he work anti-clockwise and clockwise. So it's between, it's between 10 and 1, and 10 and 0. Maybe just to modify the probability 0.8, and we are supposed to see if the probability of working clockwise is 0.8, he will like mostly work clockwise. So okay, here we got as expected. Although he never made it to 789, now we refresh, then we look at the GIF. Now with the probability going to zero point 0.8, that's a lot, a lot. I don't know. Yeah. Also, that's yeah all of the random walk in a circle simulation. Thank you, guys.